and welcome to the session where I will guide you through the journey of building a serverless web form using Amazon Web Services, Lambda functions, and of course, FileMaker. My name is Christos Savva, and I'm a senior developer at Beezwax Datatools, where I'm part of a well-diversified team of 15 or so FileMaker, web, mobile, and Tableau developers. I've been developing apps using the FileMaker platform for about 8 years now, and I've been certified in all versions of FileMaker since version 12. Recently, I've also become an AWS certified developer. I've been a frequent speaker at FileMaker-related conferences for the past couple of years. Before moving into the world of FileMaker, I was an auditor and consultant at Deloitte. I'm a native Greek speaker, so please excuse my accent. Actually, I was born and raised on the sunny island of Cyprus in the Eastern Mediterranean Sea, where I currently work from and live with my wife and our dog. In my spare time, I'm an amateur astronomer and co-founder at Cyprus Astronomy Organization, a non-profit to promote astronomy on the island. And this is a recent picture that I took of the Dumble Nebula. Serverless technology is a really hot topic now and has transformed the way apps are built in recent times. Although we're going to build a specific project for this session, what I would like you to do is to leave the session feeling inspired as well as excited about the power of serverless technology and how easy it is to leverage it for your own solutions. First off, we'll start by defining what serverless technology actually is. Next, we'll dive into a hands-on project where we're going to build from scratch using a wide variety of services on AWS and, of course, Claris FileMaker. After our demo project, we'll take a look at some stress testing results and see how our app has performed. Serverless computing allows you to run your code without the need of provision or managing any servers at all. You just write up your application code or your backend service and run it on your cloud service provider's infrastructure, which would handle all the provisioning for you automatically. The code that you're writing up is essentially a function taking in certain inputs and delivering some outputs. Most of the cases, there's a triggering event, such as, for example, a new file at a certain location. The true power of serverless lies in the ability to scale, big time. Your code can run on multiple instances in parallel to provide an almost infinite scalability to your application. Since this is an on-demand service, you pay exactly that, on-demand pricing, for the compute that you actually use. That's it. Now, remember that since we will be dealing with functions, our functions need to be stateless, meaning that at the end, they'll need to deliver their output somewhere for storage, such as a file, a log, or database, a Claris FileMaker database. Now you see where we're going with this. We're problem solvers, so what better way to learn by solving an actual problem at hand? So throughout the rest of the session, we'll focus on this particular problem statement to guide us through our learning process. Imagine there is a business that's small in size, say 5 to 10 users, that already have FileMaker database in place. This imaginary business has a large influx of data from a large number of anonymous users for a brief period of time. Think of something like signing up for an annual highlight event of some sort with thousands of participants. A key thing to note in our problem are the following: large influx of data, large number of anonymous users, small business, and more importantly, small time span. So how do you go about solving this problem with just Claris FileMaker? The web direct method is straightforward, especially to the experienced FileMaker developer. The data is fed natively into the database, and whatever you've built already in FileMaker is immediately available on the web. The problem might be that this is an expensive solution due to licensing for anonymous users. Think our problem statement again, as our business is small but needs a very large number of anonymous users, just for a small period of time. There is also the added cost and fuzz of provisioning and admitting possibly multiple servers to get the job done. Say that your user base is in 1,000, then this is definitely beyond the scale of FileMaker Web Direct. What about option B? Well, custom web application is certainly going to solve the licensing issue and the scalability. It's certainly harder to develop, and you may not have the skill set to do so, or even the budget to hire someone to do it for you. Of course, adminning and provisioning of servers is still a big task that remains at hand. The third option is essentially one form of serverless solution. It's easy as you just focus on building your form on FormStack and then map your fields into your FileMaker database via Claris Connect. Being serverless means no servers to manage and can scale as need be. There's only the cost of the Claris Connect and FormStack to consider here, but it's certainly a suitable alternative to what we'll build here. In the proposed solution that I'll show you, there are no licensing costs involved, apart from the service cost to AWS, which we'll see towards the end of the session. As we previously said, our code can scale and handle hundreds, if not thousands, of connections over a very short period of time. And remember, no servers to admin. We'll just insert your code here into the service, and that's all we are doing. There is, of course, some pro code development and will require some basic node functionality to build our main function. If you just know some JavaScript, then you should follow just fine. Now that we've built up our motivation to solve our problem, let's see what the proposed architecture looks like from a higher ground. A quick note, I'm using AWS out of preference, but you can apply the exactly same principle to services such as Microsoft Azure or Google Cloud. Starting from the bottom and going upwards, our users will be hitting our web's address, trying to access the web form. The first call will essentially be made to a domain name server such as Route 53 on Amazon or your own DNS. I'll skip this step as this is quite straightforward and we'll already have an address provided by us. Now, this will resolve the address to try and access the web form, which will be hosted conveniently and as close to the user as possible through a content delivery network, the CDN service called CloudFront. The content of CloudFront has been cached from a static web page that's hosted on an S3 bucket, Amazon's simple storage service. Yep, that's right. We'll host a web page on a simple storage. The form will then make a simple JavaScript call to an API gateway, which will be hosted our own custom API. Yep, you heard it right again. We'll even build our own custom API. Then, and we are almost done with the steps, the API will trigger a Lambda function which will call the form data and pass it over to FileMaker. We could just have easily added more features or processing to our function, but we'll just keep it simple. One further point of excitement for me from serverless technology is how AWS named it over a Greek letter, Lambda. In this section, I'll be making a short introduction to Cloud9. If you're already familiar with Cloud9, or you're comfortable with another IDE such as Visual Studio Code, feel free to skip this section. Remember, in the following sections, I'll assume you have an AWS account set up and ready. Cloud9 is a cloud-based IDE. It was founded as a startup back in 2010. 6 years later, it was acquired by Amazon Web Services and is now integrated fully into their service. You'll need an AWS account to access it. The great thing about Cloud9 is that you can write up all your code right into a browser. You can write on your desktop, then carry on working on your laptop or even your tablet. There is a debugger and terminal at hand, and it comes pre-installed with all the developer tools for most programming languages, such as Java, PHP, and Node.js. And you can even collaborate on the same development environment with your coworkers. Being an AWS service itself means that there is a seamless integration with all AWS services via pre-installed command line interface. More importantly for our session, we can write up and test our Lambda functions straight into Cloud9. So let's sign up to my AWS account. Go to aws.amazon.com, then I access the management console. I type in the email that I used when I signed up to my account. And I'll switch over to the region that's closest to me or the region that's closest to my client. Note that all your services for a particular application, they must reside on the same region for most purposes. But there are some services that are global in nature. So I'm switching over to Northern California, and here you will see all the different services that are available on AWS, and they keep on adding by the day. So I switch over to Cloud9. And there is some basic information here, so I'll go ahead and create an environment. I need to name my environment. And I go ahead and click all the leave all the defaults in and create the environment. So it's going to take a few more minutes to finish up. During this time, what AWS does is to provision an EC2 instance that's based on Amazon Linux operating system. And it's loading also from an image that has all the default tools for you. Now I've used the micro EC2 instance here, but you could have chosen a more beefed up version using higher specifications. The great thing about Cloud9 is that after 30 minutes of idle time, it will go into hibernation mode. It will be essentially disconnected, but you can reconnect straight up. So you can see here my environment is already set up for me. So I'm going to check that Node is already installed. You see, it's version 10. And also npm, the Node package module, is also installed. I need to update this using the nvm install stable command, which is the Node version module. And it's going to download everything from the latest version of Node. So now I'm using Node version 14 and npm version 6. Now we are ready to get started. On the right here, we have the registration form, which is going to be our end product. We'll ask for our users their first, last name, email, and mobile address. So in terms of FileMaker database, we have very simple needs. So I'm going to use one of the starter apps, in particular the Contacts app. I'm going to save it over to my Documents folder. And here you can see that we have first, last name, we have phone number fields for mobile, and we have an email address as well. So what I need to prepare this for Data API is, first of all, I need to secure this so that I'm allowed to upload to my FileMaker server. And here there is no privilege set for Data API. So I need to create a new account for Data API. And here I need to create a privilege set. I'll give it a name. And here I need to enable access by FM REST, which is the FileMaker Data API. In terms of layout, I only need to allow access to this layout, which is called the contact details. It's going to be view only, and the records are going to be modifiable. In terms of actual records, I only need to give create access to the contacts table and only to these two fields, first and last name, to be modifiable. For the phone numbers, I need to also be able to create phone numbers. And I need the type, number, and also the foreign key, because it's automatically being created via the relation. Same applies for the email address, type and address, and foreign key. I save these changes here. I enter in my newly created full access credentials, and I upload this to my host. I enter in my server credentials, and I upload this to my server. Now it's completed, and you can see here from the green log that it's uploaded and secure on my server. If I switch over now to my FileMaker Server admin console, under Connectors and FileMaker Data API, I need to enable the Data API to my server. That's all I really need to do to prepare my database for Data API. Let's get started with our Lambda function. Let me start by creating my Lambda function. I'm going to create contact record. That's going to be the name of my function. And on runtime, I choose Node 12x. See, there are plenty of other runtimes here that you can choose from. I create my function. Now, in this part of the session, we have plenty of going back and forth between Lambda, Cloud9, and Secrets Manager and Instant Access Manager. Now, this is quite a lengthy process, so hang in there. So our function is created for us now. And if I go over into my Cloud9, you'll see here there's a Greek letter Lambda on the right hand side. If I click this panel, you can actually see in my remote functions, I see create contact record. I can click the arrow key now, and this will import my function. See, it's automatically opening up my function. It's exactly as it is over here. So you see it says this will return hello from Lambda. If I go over on Cloud9 and I change this to Cloud9, I save my file. If I come here now, you see there are local functions and remote functions. The remote function is this one, and this is my local function here in Cloud9. If I select and upload this, if I refresh my browser now, you will actually see that my Lambda function has been updated. Now, the next step would be to create my environment variables. I need some environment variables to store my server, for example. I need an environment variable that I can set my database name, which is contacts.fmp12. We'll need to specify the layout. It's contact details. We also need the username, which is data API. But what about password? Do I enter it here and it's going to be saved as plain text? No, we have safer method to do that. We're going to use something called the secrets manager. But for now, just trust me. When we set this for the region to US West 1, which is the region here in Northern California, you can see the rest of the regions to choose the one that is suitable for you. And the secret name, which I'm going to set as contacts database password. I'm going to copy this and I'm going to save my environment variables. So if I go over here to the secrets manager, this is another AWS service, and I store a new secret. I choose the other type of secrets, and I'll need to store a key value pair. So I'm going to call this password, and this is my data API password. And the secret name, I'm going to paste the name that I used earlier. Click Next, accept all the defaults. And this is going to create my secret now. If I access my secret, I get this secret's ARN, which is the unique identifier for my secret. If I go over here to my Lambda function, if I check under permissions, you will see we only have the CloudWatch logs, which is actually logs for my Lambda function. I need to extend this to include this my secret as well. So go over here to the Identity and Access Manager, and I add an inline policy. Choose the service, which is Secrets Manager. Go over to the access level and get secret value. That's all I need to do. I just get the value of my password. And here in the ARN, I paste in the ARN I copied earlier. I review the policy. I'll name this the same name, contacts DB password. And if I come over here in my Lambda function and I refresh, I should now see under the resource summary the Secrets Manager and CloudWatch logs as before. So I won't need this anymore. So it's time to do some coding now. First of all, we need to say that in order to use the data API, I'm not going to write up entirely my function from scratch. I'm going to use something ready. That's why using npm, I'm going to use this package, FM Data API Client, which is written by Ben Scholzen. I'm going to switch over now to Cloud9, and I'm going to create a layer. The layer in Lambda function is added here under configurations. You will see the layer. The layers can store different node modules. You can have different packages of different node modules. So I'm going to create a module now. I'm going to create a folder. I'm going to call this FM API. Inside, I'll create another folder which must be named Node.js. We have to name it that way. Next, I'm going to open the terminal here. I'm going to create the npm package. I'm going to name this FM API version 1, description, give this as default, and I'm going to put my name here as an author. My package is now created. So I'm going to install here the FM Data API client package. And I need to move one directory up and create a zip of all that. So you see, my zip folder is now created, and I can download and save it over to my folder. If I go back to my Lambda here, you'll see the layers that are stored here. I'll create a new layer. I'll call this FM API, and I'll upload this from the zip drive. I choose the runtime, which is going to be Node 12. And I'll create my layer. Now my layer is created, and I'm going to copy the ARN here. And I'm going to go back into my Lambda function. I'll click the layer section here, and I will add a new layer. We'll specify the ARN and paste it here. So you'll actually see that my FM API layer has been added. Switch back to Cloud9, and I'm going to go into my create contact record, and I'm going to create a new file. This file, I'll name this secret.js. This is going to be a special helper function that's going to help us retrieve the password from AWS Secret Manager. This function gets a region and secret name. So it creates a new object for the secret manager, and using the secret name that was specified for the secret ID, we get back our secret string. And this is going to be returned to my index.js. Here in the index.js, I'll just replace this code with this. First of all, we declare our environment variable. That's how you get our environment variables that we've set here in our Lambda function. Just note that for the server, we actually need to specify in URL format, so we need to add the protocol at the beginning. And we import some libraries. First of all, the client library, which is the FM Data API client. It's going to load from our layer. And the file, which is the secret.js that we've just seen before. So now our Lambda function needs to, it's getting an event, which is the input from our trigger, which is going to be our API gateway. And it's going to return a response. The response will have a header of an application JSON. And for now, I'm just going to allow for access from everywhere. It's going to return a status of 200, and I can, of course, change this to be more in line with whatever response I get from FileMaker. And we can also get the results in JSON. First of all, we set up our secret string, which we're going to get from our file in the function. And we parse out from the JSON that we get back the password. We create our FileMaker client, and we specify the FileMaker layout that we want to go to. We create the object from our portal data, if we have any portal data. And finally, we make our call to FileMaker. And at the end, we close out our session. That's all that we really need to do. So now we are ready to deploy into AWS Lambda. So we come back here and we deploy our function. How are we going to test this? There are 4 ways that we can test. We can test using local, we can test remotely. By remotely, we actually mean here. So I'm going to run this remotely. What I can enter here, it's my event. So my event, it's going to be field data, first and last name, portal data, which is going to be the email address. I pre-specify this as personal, and the phone numbers, I pre-specify the type as mobile. If I run my test now, and everything goes well, I should get my response back as 200, and it's going to return whatever I get back from FileMaker, which is record ID. So if I switch over to FileMaker, I see that my record has been created. Our Lambda function is now ready and deployed and communicating with FileMaker. Let's summarize the steps that we just took. We created our Lambda function and we tested it over with Cloud9. We set our environment variables and saved our password into Secrets Manager. We created our FM API layer that we can use over and over again with different functions. We wrote our main function along with the secret helper function, and we deployed and tested our function with FileMaker. Next, we need to connect our Lambda function to our trigger, which is going to be the API gateway. For my API, I need to add a trigger to my Lambda function. I select the API and I'll create a new REST API. For security, I'll select Open and then add my API to start provisioning it. I can click the link here and go directly into my API. Now, we can create a fully fledged API along with documentation, different resource policies, and so on. Here, by default, it gives us this any method. I come here and I delete the method. Next, I need to create my own method, which is going to be just the post method. So it's not going to allow any other method to pass through the API. It's going to be a Lambda function. And we're going to use, we're going to keep this unchecked, because if I check by proxy, it means that the API is going to pass through not just the body of my post request, but also a bunch of other different information. So I'm going to keep this unchecked. If you want this information to pass through to your Lambda function, then you should check this box. My region is the correct region, and I'm going to tab ahead for my Lambda function. I save this, and now I give permission to access my Lambda function. So now my API is almost ready. So I'm going to test this. I'm going to come over to the request body. I'm going to paste in my test event, and I'm going to change the event to John API. I'm going to change a bit the other values as well. So if I test this, over here on the right, I'm going to see my response, which is a success. And if I switch over to my FileMaker, you can actually see that I have two records now. One is my record, and the second one is John API. So now what I need to do, my API is not ready just yet, it's still in test mode. So what I do, I need to click Actions and deploy my API. And you can choose different deployment stages here. We can have default, we can have production, we can have dev, whatever other API, whatever other stages you'd like to set for your APIs. So I'm going to deploy now. And now you see it switched over from resources to stages. Now this is my default stage, and over here, if I click over to post, you can actually see the endpoint of for my requests. I'm going to copy over this link, and I'm going to go to Postman. Now I'm going to try a GET request just to check that it should not be allowed. If I click send, you'll see that I get the message missing authentication token. Instead, if I try to make a post request with my event, if I click post, I should get a success. So if I switch over to my FileMaker now, I actually see that I have 3 records, and the third record is the one from Postman. Now, I paused the video there to preload the URL over to the registration form backend, and I'm going to create a test record here. If I try to hit submit, I get that my submission is unsuccessful. If I click inspect element, I'll see here that I get the message that the request cannot load due to access control checks. This is the usual course issue. And if I switch over to my API, if I go back to resources and click on my method, from the options, from the actions, I can choose enable course. I'll accept the defaults for now. And if I go back and I try to resubmit, it's still unsuccessful. But why is that? The reason is that I have not deployed my changes. So I go and deploy my API back into default. So if I switch over now back to my registration form, let me reload the page now and try another submission. Hit submit now, it's going to be successful. And you see here on the right that I actually got my record. So our API is nearly ready now, so let's set up our front end next. Our apps front end, it's quite simple, and it's using the semantic UI web framework, and also a bit of jQuery. The styling is quite simple and minimal, but more importantly, the main part of our function, of our application, is this function here. This function is checking first of all if our form is valid. We assign some of the URL and our data structure as we as we saw earlier, and we assign each field of the form to our data structure. Next, we make a post AJAX call to our URL where we send our data in JSON format. If we get a successful message back, we return that to the user, otherwise we return a failure. The main UI here is the body section that we have our 4 different fields plus the checkbox to agree some terms and conditions. At the bottom, we also have a section here for the form validation. So this is quite a very straightforward form. Moving now to another service, Amazon S3 bucket. Amazon S3 bucket is where we store data in an object form. So let's create a bucket which is similar to a folder, and I'll call this registration form test 2020. I'll keep this in my region, and here I need to allow public access because my frontend is going to be available to the public. Next, and I create my bucket. I click on my bucket and I upload a file, which is going to be just my HTML file. Click Next, and under permissions I grant this to our object public permissions. So my upload is complete. Now go over to properties, and here on static website hosting I click use this bucket as host. And in here, instead of index HTML, I write registration HTML. Doesn't really matter. It should be the name of my form. So now I click again to get the URL. You see now my form is available to the world. Now let's try and make an S3 test. See that my form was sent out successfully. If I switch now to my database, I see that my test file has been sent. How do we restrict that only calls made from this website is going to be sent out to my backend? I go back here to my API gateway. Under resources, I click options. And here on integration response, click the arrow key again for the header mappings. Click the little pencil icon here. Inside single quotes, I paste in my S3 URL and I save this. I click save. I go here and I deploy again my API. Let me now go back to my registration form. I refresh the page. It's test 2. If I try to submit now, it should be successful also. Go here, back to my FileMaker. I see that my test has been successful. So if I switch back to my local registration form and I try to make a submit, it's gonna fail. Great. So now our app is ready for the world. Well, almost. There is still one more step to do. Our app is nearly ready, but instead of hosting it over on S3 buckets, which are in limited number of regions around the world, there are still large distances from between our users and the region's data center. Instead, we'll use a content delivery network, which has more locations, and it's called CloudFront. Let's go into CloudFront and create a distribution. Creating a distribution for the web, and select our bucket. We'll restrict our bucket and create a new identity. We want to update the bucket policy for our S3 bucket. We'll keep redirecting traffic from HTTP to HTTPS, keeping the rest of the default options. We scroll down now here, we can actually see whether we want to restrict to US, Canada, and Europe only, or to all other edge locations. We can enter alternate domain names if we have our own domain name, but we'll keep this option here, which is the default SSL certificate. It's going to be a .cloudfront.net subdomain, but that's okay for our example. So we are ready to create our distribution. Which is going to take some time. So our distribution is now ready. So this is going to be our page's domain name. So I come over to my browser and I enter in the address. At the end, I need to enter the file name. See how fast it loads now. Now, more about that in a moment. If I click into my distribution, I need you to notice this invalidation tab over here. So if I want to make any changes to my S3 bucket, I first need to upload a new copy of my file there. And here I need to create an invalidation. If I want to invalidate all the files of my distribution, which are cached around the world, I need to enter / and the star symbol. So I click invalidate, and it's going to take some time for this to refresh over to all the edge locations. So it's time for some stress testing. So if I go over here on my browser and I enter in the address that I used earlier, watch how long it's going to take. Okay, now I'm going to pause the video until my distribution is ready, and I'm going to come back and we'll see the improvement. What about pricing? Surely you must think that this is going to cost a lot. However, the cost of Lambda is quite minimal. It's actually based on memory allocated and duration of execution. In our example, the function is provisioning 128 megabytes of memory and only uses a maximum of 93 for every run. So the first pricing tier applies in this case for every 100 milliseconds in duration. From load and stress testing, you will see that that's actually about 1800 milliseconds. So if you do the math, that's about 250,000 runs for just $1. Wow! You can see here that the other services don't cost that much either. The API gateway is only $3.50 per million of requests received per month. that's just coffee money. AWS pricing is very complex and tiered, so I'm just showing some basic pricing here, and you should look over on their site for more details. But you can already understand that this structure is quite cost effective. In terms of performance, I use a tool called JMeter, where I could simulate 1,000 virtual users. These users could be ramped up over a specified period of time. The simulation was basically a GET request for the registration form page, a random wait time of about 2 seconds for the user to kind of think about the form, and then POST request to the API endpoint and simulate the form submission. The server I used for FileMaker was an EC2 instance, T2 medium to be exact. Now the FileMaker server had only one open file and 800 megs of cache allocated. And this is certainly a small server, and it's customary to see the next tier of EC2 instance for a small business. The first kind of load test I did was to run 25 transactions every second. That's ramping up 1,000 users over a 40-second period. The FileMaker server handled this smoothly and gave us a baseline of 1.8 seconds for the Lambda function, i.e. the registration, and 0.4 seconds for loading the page, as you will see on the top left chart. On the bottom chart, you'll see that the average of 25 transactions happening every second. On the right, you will see the exact same result, just using CloudFront. It looks almost the same, but if you look a little bit closer, on the red line on the top right-hand chart, you will see that it's just a bit less than 200 milliseconds for just loading the page. That's 50% improvement of S3 compared to CloudFront. Small here, but it's accumulating for larger and more complex pages. We're repeating the same test, but ramping up the users over a 20-second period means that we achieve a steady load of 50 transactions happening every second. This put a lot of stress on the server. As you see on the top left, the Lambda function took longer and longer to run due to the FileMaker server being put under stress. All transactions went in fine. At the end, some data API connections were left lingering. For a higher number of transactions, the server could not cope, and less than 1,000 records were created, and about 500 data API connections were left lingering at the end. If we compare the two red lines on the two top charts, you will actually see over that S3 took over 0.4 seconds to load, and over CloudFront 0.2 seconds. That's the same consistency as before. Now, our serverless journey for this session is ending, and I hope a new journey will come into your minds. Think about what you can do with this power. Let's say you want to leverage Python or Node libraries to process data, set up in Lambda and create your custom API endpoint, and push data from FileMaker. This way you can keep your server requirements to a minimum. Look up into more services on AWS. Pretty much most of them somehow interact with Lambda. You can subscribe users to simple notification system and send out SMS. I'm sure you'll find many more applications. So I'll ask you, are you feeling inspired about the power of serverless?